Good evening, everyone, and welcome to this today's session of Saturday Talk. We have Shri Ramalingam Shantha Kumarji for today's talk. Little brief about Shantha Kumarji. Shantha Kumarji completed his Bachelor of Engineering in Electrical and Electronics in the year 1985. He is affiliated to Madras University. He also have won awards for his project work fusion plant, distance relaying in transmission system, among others, in national and regional contests. As the first step to a peaceful use of nuclear fusion. An engineer and entrepreneur with over 35 years of work experience in some of the country's largest corporate houses, contributed to the growth and consolidation of few startup companies as well. Currently serving as the Chief Executive Officer at eCloud. Santha Kumarji is currently the President of India Taxpayers, an association of taxpayers in India, and Indian representative in the World Taxpayer Association. He is a sitting member of Tamil Nadu State Infrastructure Panel of Federation of Indian Chamber of Commerce and Industry. He also currently serves in Industrial and Business Associations in their executive councils and committees. Today he is going to speak on the energy evolution, navigating tomorrow's power landscape. Chandrakumar sir, over to you from here. Thank you.
Thank you. Thank you, Rajesh. I think you've given a fantastic introduction. Well, I've spent most of my later days after college on energy and process industries, and been working in companies like Tata Consultancy and in SPIC, Southern Petrochemical Industries, till about 1992. I would say the industrial scene was changing, and we started connected with this energy power industry. This is where I am. We've been from 1992 onwards. Today is 2024, and for almost 32 years spent time on energy and energy evolution, how energy could be used in various industries, and particularly on the electricity side. Somehow, over a period of time, we have been having only one form of energy most commonly used in our day-to-day lives, and that is electricity. So whenever we talk of energy, people immediately think of mostly electricity and how the energy cycle. If you look at how the whole planet works, you will find that when we say energy cycle on a planet scale, it's possibly we look at it in two separate cycles. One of them is the energy cycle that we normally refer to in terms of the solar heat coming into the planet, heating the temperature, heating the various layers of various layers of atmosphere, and that in turn resulting in movement of air, which is possibly the whole system of atmospheric heat, atmospheric behavior, water, rains, etc. And all these things are a part of the energy cycle. This is possibly what is normally referred to as the smaller or lower level of energy cycle within the planet. Other larger energy cycle is what is normally referred to as, this is what I was mentioning about the smaller energy cycle. And if you look at the 100,000 year cycle, that is the larger energy cycle, you look at how the ice ages, which were followed by interglacial periods, you see that energy that is coming into the planet gets trapped in your whatever in the previous smaller energy cycles, that gets trapped, and the heat of the planet increases gradually. A warmth is reached over a period of time, and this warmth eventually results in a large water body which evaporates and produces torrential rains, which in turn again cools down the planet. This glacial and interglacial periods keep occurring one after the other in a cycle, and this is primarily from the ice age, and then you go to the glacial period. So every 100,000 years, this glacial and interglacial period cycle, which is really the energy cycle of the whole of the planet, is created. This cycle we lose track of. It's not that we are the only guys who are warming up the planet. The planet itself is designed to get warmed up. It is that way. So eventually, if you look at the way the life of this planet has been progressing, you find that we are primarily accelerating this process. We are a part of the nature scheme of things. If in the previous cycle, possibly there were lots of volcanoes bursting out the heat, and therefore they were causing the global warming to a greater degree. Nature itself has generated heat inside the planet. But as the planet cooled down, the natural cause of heat creation slowly subsided. So it needed something else possibly. And possibly the man was the creation of nature to bring out the heat that is lying inside the planet and to heat up the exterior atmosphere so that the cycle continues. So we are somewhere in the interglacial period, which essentially is going to get heated up. And as we reach the heat, the larger temperatures, it's going to result in torrential rains. And all these cycles need to occur. So what is happening in the energy sector is today the question mark over, are we going to follow this nature's law of energy cycle, which is primarily ice age, the interglacial period, warming up, again cooling down, ice age again. So this cycle, which has been going on happening in every 100,000 years approximately, should we just succumb to this natural cycle, or are we going to do something about it? That is what is the question that is currently standing right in front of us. And whatever we have been doing is the acceleration of this climate, this warming up of the planet. Yes, it is going to happen either way, but are we going to help this warm up accelerate, or are we going to help it decelerate, possibly try and reverse it? So this is what is the big question in front of us. Why should energy be the cause of concern? Because the biggest industry that is causing global warming is energy industry. So, and then of course transport, not including aviation. Aviation is of course a major cause, but even if you include aviation, transport does not supersede energy. So energy creation is the biggest global warming industry as of today. So yes, as this graph indicates, you find that the warming has accelerated over from 1940. You find that it has been going up on a very steep path, an exponential increase in the warming. So this is something, if we want to really reverse, every one of this matters. All industries matter, even the land use change and forestry, everything. This is the possibly I've listed down as the sixth one, but some people used to call it as the third or fourth cause of global warming. Simply because it has been happening from time immemorial, meaning we have been converting land use for almost 4,000, 5,000 years. So that is also having its impact today. This is the reason why the energy industry needs some attention, and that is causing a major transition, a paradigm shift in the way energy is going to be used in the future. Electricity, as I was telling at the beginning of the talk, energy somehow beats electricity as of today. Though, of course, many other forms of energy will take precedence as we move on from now. Because the direct usage of energy is going to conserve, is going to make energy more efficient, usage more efficient. So you find most of the houses today have a solar water heater on top of the building. That's a direct use of electricity. And all said and done, electricity or whatever form of energy that you're using on this planet, the primary source of that energy is the sun. So energy will eventually come from the sun. So let us look at what are the major twists and turns that we expect in the electricity business and usage of solar as a source of energy. So as I said already, the solar will be one of the mainstays of power. And there is a technology change that's happening literally every day, every hour. So you find that what we use when we started off putting up a solar plant in, 2005, the PLF was somewhere around 16%, which essentially means for 1 megawatt of power, we will be generating something like 14 lakh units of electricity, or possibly even a little lesser. So this was the scenario with the solar power plant 2005, 20 years back. And today, the plant capacities have been going up. 24% PLF is very common, and what we are talking of is about 5 lakh, 20 to 21 lakh unit generation from 1 megawatt of solar power. But is this a major improvement? No, not really. If you look at these other efficiency of other systems, for instance, the computers that we use, for instance, if you look at the efficiency of operation, the last 20 years of computers, you will be stunned. From a large computer has now been condensed into a large mainframe computer, I should say, has been condensed into the size of a mobile phone today. So that is the growth of technology in all other spheres of engineering, whereas in case of solar, it has been very, very marginal. The improvement has not been great. Though, of course, we foresee some improvement in the days to come to reach something like 35 to 40% efficiency in perovskite. That is what the new material that people are talking of as a replacement for the semiconductor. That is so. This is possible will possibly improve the efficiency of operation substantially, and the HJT or heterojunction technology. That is also something that is that's being predicted as a major change in it. So this is the understanding of the natural working of animal and plant bodies that somehow we have not really strived to or we could not achieve. I think it was possibly one of the major issues that we normally I used to think the cause of the current problem that we are facing today. And I think in my last talk with you also I was referring about it that we migrated or we moved out of the nature's way of working and we thought we were intelligent when we invented the wheel and we thought we have four-seeded or we have kind of superseded nature and try to build by inventing the wheel. Nature never invented the wheel. Even today, nature has not invented for no movement, but we invented as human beings the wheel, and we thought we have done something great. Well, that possibly was the cause of deforestation, the roads, so many other things, which eventually led to the situation that we are in today for a faster global warming. Okay, now the other side of using any renewable would be the storage. The reason why the storage is required, look at the wind turbines or the solar power plants, which form the main thrust of renewables today. The rest of the renewables are they are literally dying down slowly, except for the new ones that are being identified and trying to bring back to commercial life. So all these renewables have an inherent problem. They are infirm power. The infirm power needs storage of power, and this storage, do we have the capability to store electricity? Till today, efficient storage is still eluding us. If you look at a pumped storage, it's about 40% efficient. The hydrogen is as good as pumped storage. So, and if you look at the other kind of storages like batteries, they claim 92%. They use huge amount of natural resources, and but most of the batteries work at between 80 and 85% efficiency. So your loss is still over 15% the electricity that you generate. So when this is the current issue. So what really transpires is that one, try to create or generate energy in a situation or in a way that you will not require storage. So these two, this is possibly the methodology to ensure that there is a continuous generation and you try to avoid the storage. As far as the solar system is concerned, it is day and night for India, but for the Earth, and for the Earth, it is not so. Some phase of Earth is always facing the sun. So this is the primary purpose. Why about one grid across? I think we were talking about a grid in one of the last talk. I don't know whether I spoke about that to you or not, but what we are doing today is not just the grid that spans the entire country. We are also having pan-Asian grids, South Asian grids. So all these things would eventually mean that one grid will span the entire Earth. That would mean at wherever, whether it is Africa that you generate power or in the Americas, you can still transmit the power across the globe to India. This is the idea of one sun, one earth, one grid. Again, that is primarily to avoid the storages. So the need for storages, that's why I made the third point, need for storages will vanish over a period of time. But what that period of time is the big question. The generation of power from various sources and how we avoid these storage mechanisms. But can we really avoid it? There are mechanisms that are being employed. It could be cases like, in case of transportation, more and more rail systems are being discussed of, and that would eventually, rail kind of systems. So, and I could see on the other front, last time when I was visiting some of the hydropower plants in Karnataka, where there are lots of micro hydropower plants, small hydros. I would rather call them as micro because they are just of 2 megawatt, 1 megawatt, 2 megawatt size. Less than 1 megawatt size generators were placed, and together about 3 or 4 together, giving about 1.8 or megawatt of generation. And the head of water was just about 8 meters. They were saying 8 meter plus 10 meters, they create a head and then they generate power. So this is happening with Kabini, with Kaveri, at all points. They are putting up at multiple levels. Every 20 kilometers, we could see small hydropower plants coming up. So I think we are tending towards things like that, where if you look at those small hydropower plants, it's some kind of smoothing out of the water flow. It's not that we generate like whatever happens in wind turbines. When the wind flows, you will have to generate. In case of hydro, what we do is we generate, but at the same time there will be a storage for at least 3 days. So it is not a stop and start. It is more like start running. You will certainly be running for the next 3 days or 5 days for sure. So there is a continuity of power. It's almost like a smoothing of power flow. It's not like as infirm as it is in the case of wind. So those things are also happening. Small micro hydro power stations just capitalizing on very very small head, such as 8 to 10 meters. So these kind of existing technology improvements are also happening on a continuous and regular scale. So this will be certainly bringing in substantial changes on the future system, and that will also avoid power energy storage. That's the final bottom line. That's going to be the major game changer. As of now, the wireless charging is all that we have, like putting up the phone onto the mobile phone onto a wireless charger. But that's just possibly the beginning. And you have to move on to a wireless charging at a distance of, let's say, 1 feet, half a feet. And that could change the way the transportation industry works, as I was telling moments back. See, it means that you can be charged as you move. When you are at a signal, when you are at a when you are parked somewhere, and you just do a wireless charging of 1 meter, then the batteries that you have got on your car could be charged very quickly. But even the batteries in themselves, if you are charged on the road as you move, then the size of batteries could substantially come down. That is whatever the guys are working on the space side, the technology that they try to create, when it comes down to some of the layman's use, it changes color and it becomes a great advancement for our own usage. So that is what I thought I should bring to you. The next steps, what we feel should be the way that things are really happening. Maybe I am foreseeing into the next 100 years possibly. There is lots of research that's going on in terms of the way the energy is being used. See, electricity is the kind of form of energy that we are currently employing. But do we use electricity as it is? No. If you look at 90% of the cases, we don't use electricity as it is. As a matter of fact, I would say even 100%, we don't use electricity as electricity. We use electricity in the form of either for a rotary movement, we have motors running, maybe to pump water, maybe to heat, maybe to cool. So electricity is actually an intermediate energy form. And that energy form might, over a period of time, could get replaced with the actual direct usage of energy, like what I was mentioning, solar energy directly producing heat, and you use it as it is. In most of our the natural systems, you will find the energy really goes into directly as what it is being used, be it in our human body, be it in plant bodies. You will will still find it gets used or converted to a farm that is directly used, not into an intermediate farm, except in cases where, like, energy stored in muscular bodies. But that is how. So this is what is the most important thing that could be affecting the way that we are leading our lives, and energy being the major component in the whole scenario for our survival. And we might have to move our lives closer to nature, but well, technology will eventually take us to it. We will have to evolve the technology that brings us closer to nature. Thank you. I think I brought help. I think that is just what I wanted to share with you today. Maybe some of my thoughts are really different, or maybe I don't know how you view it, and maybe many of the other ideas and thoughts you already know them. But if you have any further questions, do come out and we could possibly share our thoughts on that.
Yeah, good evening to all. And really, it is very nice lecture. I think I'm very happy to listen. And maybe I learned a lot because he talks about even glacial to interglacial, even nature itself takes care of warming and other things. First time I'm also hearing. Maybe I thought we are only abusing, but nature itself has its own cycle. Maybe he himself said it is a cycle time, maybe in thousands of years. So we are only nothing. Our life is only 100 years or 60 years or 80 years. It's a very good thing. But maybe I have few questions to Shantha Kumar. I'm slightly disappointed he didn't talk much about hydrogen, because I always feel future storage and our pollution and warming and all those things, the answer is hydrogen. So he mentioned a little bit for storage time. So that is one point. Second is recently I heard prosumers. Nowadays, if you produce the power in power stations, if you bring it to the town or village, the loss is so more than 50%. Not only copper loss, even theft also is there. That's what I heard from some of the electricity engineers. So finally, what we are getting is a very small quantity. That's why the cost is also so much. So the prosumers you produce and consume. So specifically in India, we are all in village, the thousands and thousands of villages. And is it not with the solar? Can we have you produce and use there itself? Such kind of thing, whether you have done any work for the government to tell, or that is one point I was looking. Then another one, years we are talking about thermal gradient in the ocean. Maybe I still remember Dr. A. Muthanayagam, he made a very big talk that even ocean department, at that time he was there, he proposed a very big energy plant, because we have so much of sea line, so we can produce a lot of electricity. But somehow that was not taken very much care about this one. What is your view on that, Shantha Kumar?
Yes, sir. Yes, sir. Sir, you were well. Some of the points that you were raised, at least the last point, I could not hear proper. Let me just answer the first few points that you raised, and maybe I might request you to repeat the last question that you were talking about. The one about the storages, you were referring to hydrogen-based storages. Sir, it is still, in my opinion, it is still an unproven technology. But of course, it also opens a huge amount of opportunities, and possibly rather that could evolve for to store, retrieve power or energy from hydrogen, and then of course you convert or produce just water as an when you let out into the air. So its cleanness, all those things are beyond any questions. Those things are absolutely great. In order to produce green hydrogen, we use again green power. So in most of the cases, but there are also cases where people have claimed that there is no need to use power at all. We will still be producing, like whatever I was mentioning, removing the electricity as an intermediary. So even to produce the green power, we use electricity. That's again bringing the intermediary called electric. So now there is a process. Last time we were discussing certain Italian process, which people were talking of, and in producing green hydrogen without using green electricity. So of course, there are multiple options on this, like blue hydrogens and all those stuff. I really don't want to get into that. Yes, hydrogen is a grand option for storage and retrieval, sir. As far as I know about it, the efficiency of generating hydrogen itself is about 40 to 45%, and reusing back in an IC engine or any other engine again brings it down to 25%. So we are losing huge amount of power there. That is the one that people are fighting against now. Researchers are working in order to make it more efficient. So that needs to be improved. This is my opinion and my understanding as far as the hydrogen usage is concerned. So, but the major shift which you were referring to, which is very, very true and which is happening, is in the solar, or as you rightly use the word, prosumers, the producer and consumer part, which is the generators happening at every home, every industry. That is where I feel the revolution as far as the electricity generation is going. If you are looking at electricity generation as the major stay that is going to be for our energy business, then this is the major shift that is happening now. It's as good as whatever internet was for the communication industry. For energy industry, the major shift will be the distributed generation. The distributed generation means every rooftop we have a power generation facility, and everybody becomes a prosumer. This, I feel, will be the game changer as far as the power generation and consumption is concerned. Yes, in that case, it is power generated and consumed at the same place. So the transmission losses substantially come down. So theft continues to happen, and transmission loss, as of today, the allowed transmission loss maximum we deduct is around 7.81%. As a power trader, this is what we do. So I inject power, X quantity of power, and I receive 7.81% less power at the consumption point. This is in case my transmission voltages are 11 kV. If most of the theft happens at lower voltages, 440 volts and lesser. So HT theft doesn't happen unless it is very, very organized. So this is the loss minimization thing and transmission. There's lots of, you were raising that point also. And I think with distributed transmission, with distributed generation, transmission losses will substantially come down. So there are no second thoughts about it. And people are working on reducing power transmission losses, particularly because the transmission is now becoming lengthier more and more, like across the country, and you're losing huge amount of power. At 730, high at 720 kV DC, the loss is supposed to be much, much lesser. So that is the level of working. Higher voltages is the one that is going to save the transmission loss.
Thank you.
Yes, sir. Welcome, sir. I hope I answered you. But what were you asking in the last second part of the question? I'm not very sure.
Well, I was asking about thermal gradient. And long back, oceanography or ocean department, they have started creating, power from the ocean with a depth of, say, 10 meter or 20 meter, keeping the surface temperature and the lower temperature. They want to get a beautiful project I have seen, but it was not properly. Any idea of why it could not come up? We are only talking much about so many things, but nothing.
It's not so straightforward, unfortunately. But yes, I think people are still working on it. People are. Last time when I was near what is that coast near Nagapattinam on the southern coast, people were doing some project related to this also, and I think it is happening, sir, across the world. Studies are being done. So
okay, I was thinking about what you said about the energy conversion without going into electricity, direct usage of energy. Like there are, I wonder how, uses of energy are light, sound, heat, motion. Basically, like, I don't know whether anything else is there. Heat, light, sound, motion, right? These are the four things you need energy for. If you want to convert energy to energy, how do you obviate the usage of electricity as an intermediary? I fail to understand that. In motion, for example, motion, the efficiency is very high only in electric motor, not in any other thing. So we know that. So this I'm surprised how energy to energy, how people with skipping the intermediary of electricity, how do you go energy to energy? Except in possibly light or possibly heat in some cases.
Yeah, light and heat, I'm sure you will straight away
Correct.
see how things. See, today you have these reflective lights, which bring the daylight into the building. So those kind of channelized lights, the reflective lights, not electric, nothing to do with bulbs. They bring the lights from the topmost floor to the interiors of the, like your buildings, to your rooms with the reflection methodology. So that is, light is, of course, I'm sure you will be able to look at it much more
relate to that.
Simple. Yes, we could easily relate it. But what also could be done is if you look at the normal motion, earlier thing in the automobile, you use chemical is directly getting into the rotary movement, right? So that is a direct conversion of chemical to movement without the electricity coming in. Now, when you are looking at electricity to motor, you are looking at only the efficiency of one conversion. We should look at both the conversions from, let us say, from an IC engine, like a diesel generator, to electricity, and then electricity to the motor. See, in our current operating methods, we still do not have an efficient transmission system of movement. So even in a diesel engine, what we do in a diesel railway engine also, what we do is we have a diesel engine which generates power, and the power is transmitted to the wheels, where the motor is placed. So we are comfortable handling electricity. That's what I'm trying to tell you. So
sorry for interrupting you, Shantha. The energy is concentrated. Presence of energy in idle. It's not spread, like except in solar and wind, where you have everywhere across the world, across the streets, across the houses. The energy is concentrated. For example, idle, it's concentrated. I'm talking big idles. Thermal, it's concentrated in the power plants. You can't have for a capital cost to be very high. If you want to put up n number of mini thermal units, the capital cost is prohibitive. So I don't know whether the economics will work out that way because of the economics I'm pointing out. This thermal side is one, and also nuclear, for example. Nuclear is a very, very clean energy. Very clean energy. I could say cleanest of all. So why not nuclear?
Very true. Very true. That is, nuclear is a possibility. I was also just passingly mentioning that they will continue to be the base load or the base station for our normal working. It could be like that for quite some time in the future. What I was referring to when I said direct usage of energy was cases like this, where you directly employ light. Currently, we use electricity, convert it into light and use. But the methodology of using light directly will take precedence in the coming years. That is what I'm trying to tell you. So this will possibly reduce the amount of electricity usage, and possibly we may remove the intermediary, but it may not be possible so easily. It is not a solution that's available tomorrow morning. But there are guys, I've seen one of the plants in where they use, which is an MSW, the municipal solid waste plant, where they generate heat, and heat is not used to generate power. It is also used to generate heat, which is given to the houses nearby. This is happening in a place in Italy. So this was what he was trying to sell in India. I said, in India you don't sell heat, right? But we don't have a requirement for heat here. As a matter of fact, we want the opposite. We want it cooled. So what we require is a different kind of a need. So how we make use of this is primarily its technology needs to evolve over a period of time. I'm looking at this as a possible option, and heat and light is something that we could
Understood.
straight away go
Understood.
for major usage.
Understood.
But the rest of it, it has to take its time and evolve.